Lab 1, Constant Velocity, in this fundamental principle of Newton's second law. This lab focuses on the observation of an object in constant velocity, meaning, as time passes, the position of the object changes as the speed and direction of the object remains the same. This is part of Newton's second law, which states the final velocity will equal the initial velocity, plus the sum of the net forces divided by the mass, multiplied by the change in time. If no net forces are acting on the object, then the final velocity equals the initial velocity. In my lab, I rolled a kickball across the table. Using Tracker, I analyzed the motion of the ball, and I graphed its travel. Using Python, I created a function from the data of Tracker to create the perfect case in the predictable constant motion. The data from both, I created an Excel spreadsheet and graphed both data, in which my data from Tracker supported Newton's second law. As seen in the previous slide, I used Tracker to analyze the motion of the kickball. Once the axes and the center of the ball were established, we tracked the motion of the ball. As the x-axis was the horizontal axis and the y-axis was the vertical axis, we analyzed the ball's motion across the table. Afterwards, we created a graph of the data, proving the velocity was constant, meaning no forces were acting against the kickball while moving across the table. Using the data from Tracker, I found the initial position and the initial velocity of the kickball as it rolled across the table. From there, we used the coding system Python. In Python, I created a function that would, written for the situation, for constant velocity, in which no error would be involved and the ball would be in constant velocity the entire time. As graphed in Python in the following pictures, the velocity remained constant, agreeing with the part of Newton's second law stating if no net forces were acting on the ball, the final velocity would equal the initial velocity. Using the data from both Tracker and Python, I used Excel to create a spreadsheet and then a graph of the data, shown in the slide. The data from both Tracker and Python are very similar, shown in the graph, because both slopes are in the positive xy direction and very constant, proving that if there was no net forces acting on the ball, the final velocity would equal the initial velocity, first proven by Newton's second law. Though the data of both graphs were very similar, they differed slightly, since the predictable graph had perfect constant velocity, while what actually happened did not. Some errors that may have caused this are the flatness of the surface in which the ball rolled on, the break in between the tables, and while tracking the motion of the ball, not tracking the center of the ball as perfectly as could have been done. There were a few more questions asked in this lab. The axes were flipped in which the x-axis was vertical and the y-axis was horizontal. What would happen to the slope of the line? In my observations, the velocity of the object, which is the slope of the graph, would remain positive. The only difference is the slope would be less vertical and more horizontal because of the slope formula rise over run, in which the y is now horizontal would be larger than the x, which is now the vertical. As well, there was the question asked if we could observe the amount of pushes and pulls which would equal a net force of 0. In the case of this lab that I observed, I think that we would be able to see how many pushes and pulls would equal the net force of 0, because the push of the ball would equal the inertia of the ball to continue going, in which the velocity would remain the same as no other forces were acted upon it. In conclusion, the ball did roll in constant velocity, proving Newton's second law, because, as shown in Tracker and in Python, when no net forces are acting on the object, the initial velocity of the object will equal the final velocity of the object.